There is a living room in Holmes County, Ohio, that has not had a gas line running to it in the entire history of the house. No electric baseboard heater has ever been mounted on its walls. No forced air vent has ever been cut into its floor. No thermostat has ever been installed beside its door because there is nothing to set a thermostat to, nothing to regulate, nothing that cycles on and off in response to a number on a dial. And yet every single winter, through the kind of Ohio cold that drops below zero and stays there for days at a stretch, that living room is warm. Not tolerably warm, genuinely, deeply, radiantly warm, in a way that anyone who has sat in it during January will tell you is different from the heat a forced air furnace produces, different in quality, different in how it feels against the skin, different in the way it persists through the night without anyone waking to adjust anything. The average American household spent just over $1,900 on home heating in the most recent winter season, tracked by the Energy Information Administration. That number has been climbing consistently for a decade. Utility companies that supply natural gas and electricity to residential customers reported record revenues across the last 3 consecutive winters. The insulation industry, the smart thermostat industry, the programmable heating system industry, and the energy audit industry have all grown substantially as American homeowners look for ways to reduce bills that keep rising regardless of what they do. The conversation in most American homes about winter heating is a conversation about managing an expense that nobody believes they have any real control over. The Amish have a completely different conversation. Their conversation about winter heating is a conversation about materials, mass, wood management, architectural logic, and the specific physical properties of stone and brick and clay that have been understood and applied by people who heated buildings without utility. Companies for the entire span of human history, before the 20th century, reorganized everything around centralized energy infrastructure. The knowledge that keeps that Holmes County living room warm in January did not come from an energy consultant or a utility company or a manufacturer of heating equipment. It came from generations of people who had no other option and who consequently paid a quality of attention to the problem of winter heat that people with a gas line and a thermostat have never needed to develop. What follows is a documented account of the specific methods, materials, and architectural principles that Amish households across Lancaster County, Pennsylvania, and Holmes County, Ohio, use to heat their living spaces through winter without gas or electricity. These are not primitive workarounds. They are sophisticated thermal systems that in several cases outperform modern forced air heating on the metrics that actually matter, which are comfort consistency, air quality, fuel efficiency, and the total cost of keeping a family warm across a winter season. The heating industry does not discuss these methods in any mainstream forum because there is no product to sell at the center of them, no subscription service they support, and no recurring revenue stream they generate. Understanding them does not require a purchase. It requires paying attention to physics that has not changed since the first person stacked stones around a fire and noticed that the stones stayed warm after the flames went out. The first method is the rocket mass heater, and it is the one that generates the most genuine disbelief in people who encounter it for the first time, because the performance numbers seem incompatible with the fuel input until you understand the combustion mechanism that produces them. A rocket mass heater is built around a principle called a J-tube combustion chamber, a configuration in which the fuel feed, the burn tunnel, and the heat riser are arranged in a J shape that creates a powerful natural draft, pulling air through the fire with enough velocity to achieve near complete combustion at temperatures that a conventional wood stove or fireplace never approaches. The significance of complete combustion is both thermal and chemical. A conventional wood stove operating at typical draft conditions converts somewhere between 50 and 70% of the wood's chemical energy into heat. The remainder goes up the flue as unburned gases, creosote, smoke, and particulate matter. A properly built rocket mass heater operating under good draft conditions achieves combustion efficiency between 85 and 95%. Nearly all of the chemical energy stored in the wood becomes heat. Almost nothing is lost up the flue. The exhaust leaving a well-functioning rocket mass heater is nearly clear, nearly odorless, and dramatically lower in particulate matter than the exhaust from any conventional wood-burning appliance. The heat generated by this near-complete combustion does not go directly up a vertical chimney the way heat escapes from a fireplace. It is routed horizontally through a long thermal mass, typically a bench or a platform built from cob, brick, stone, or rammed earth, before exiting the building. As the hot exhaust gases travel through the interior of that mass, they surrender their heat to the surrounding material. By the time the exhaust reaches the exterior flue, it has lost most of its thermal energy to the mass, which is why rocket mass heater flues run at relatively low temperatures, and why the exterior exhaust is so much cleaner than conventional wood-burning exhaust. The mass itself then functions as a thermal battery. An Amish family loads the rocket mass heater once or twice per day, burning a fire for 2 to 3 hours that drives the internal temperature of the mass up to the point where it has absorbed the equivalent heat energy of a much longer, lower intensity burn. That stored energy then radiates steadily from the surface of the mass for the following 12 to 24 hours at a surface temperature that is warm to the touch, but not hot enough to cause burns, filling the room with radiant heat that warms objects and people directly, rather than simply warming the air the way forced air systems do. The fuel requirement for this performance is what stops most people when they first encounter it. An Amish household heating a living room through a full winter day and night with a rocket mass heater may burn the equivalent of 3 to 5 small diameter pieces of wood per firing. Not a full cord, not a rick. A bundle of material roughly the diameter of a human forearm and a few feet long, consumed in a 2-hour burn that charges the mass for the next day. Users who have transitioned from conventional wood stoves to rocket mass heaters consistently report reductions in wood consumption of 60 to 80% for equivalent thermal output. Amish builders who have used this technology across multiple construction projects report that a properly sized rocket mass heater and bench installation can keep a living room of up to 2,000 square feet at comfortable temperatures through a Pennsylvania or Ohio winter on approximately 1 cord of wood per season, a quantity that a conventional wood stove might consume in a month. The second method is the masonry heater, which is the European ancestor of the rocket mass heater, and which operates on the same fundamental principle: store heat in dense mass during a short, intense burn, then release it slowly over the following hours. Masonry heaters have been heating homes in Scandinavia, Russia, Germany, and Austria for several centuries. The Amish communities of Pennsylvania and Ohio, many descended from German and Swiss settlers who carried this building tradition with them, have incorporated masonry heaters into their homes as a primary heating method in a way that most American home builders have never encountered. A masonry heater is built entirely from fired brick, soapstone, tile, or a combination of these materials, with a firebox, a combustion chamber, and an internal flue system that routes exhaust gases through a long serpentine path within the body of the heater before allowing them to exit. The path length of the internal flue is the critical design element. By the time hot exhaust gases have traveled through 6, 8, or 10 feet of internal flue channel, winding through the dense masonry body of the heater, they have surrendered the vast majority of their heat to the surrounding mass. Exhaust temperatures at the exterior flue of a well-designed masonry heater typically run between 100 and 200 degrees Fahrenheit. Compare that to the 400 to 700 degrees Fahrenheit flue temperatures of a conventional wood stove, and the difference in heat recovery tells you everything about why the performance numbers are so different. The body of a masonry heater, charged by a 2-hour fire of dry hardwood burned hot and completely, reaches internal temperatures that drive the exterior surface to between 150 and 200 degrees Fahrenheit. That surface temperature is sustained for 18 to 24 hours, radiating heat into the surrounding space continuously without any additional fuel input. The living room around a masonry heater does not experience the temperature cycling of a forced air system. Forced air sends periodic blasts of warm air followed by cool periods between furnace cycles, which most Americans accept as normal indoor winter experience. The room instead experiences a steady, even warmth that radiates from a large, warm surface in all directions simultaneously, warming walls, floors, furniture, and people through direct radiation rather than convective air movement. AIR quality is one reason people notice the difference immediately when they enter an Amish home in winter. Forced air heating dries the indoor air to humidity levels that damage mucous membranes, increase susceptibility to respiratory infection, cause static electricity, and crack wooden furniture and flooring over years of seasonal cycling. A masonry heater does not move air at all. It radiates. The humidity level in the room stays at whatever level the occupants and their activities naturally produce. Amish women who cook, who hang laundry indoors, who keep houseplants, and who breathe, sleep, and live in the space maintain an indoor humidity that forced air heating destroys entirely. The warmth in an Amish living room, heated by masonry, feels different from the warmth in a centrally heated modern home for a measurable physical reason. It is warmer at body level and at floor level than at ceiling level, the opposite of what forced air produces, and the air itself carries moisture rather than being stripped of it by a system designed to move air regardless of what moving it does to the people breathing it. The third method is the coal stove, and it is the one most historically embedded in the specific geography of Lancaster County and Holmes County, both of which sit within reasonable distance of the Appalachian coal deposits that supplied Pennsylvania and Ohio households with solid fuel from the mid-19th century through the mid-20th century, before natural gas distribution infrastructure made coal delivery economically uncompetitive for modern households. Amish families in these regions maintained their coal stoves through that transition because the transition required adopting utility infrastructure that their communities had chosen not to adopt. And what looked like a deprivation from the outside was in practical terms a continuity of a heating method that worked reliably, cost less than its replacement, and required no ongoing relationship with a utility company whose rates could change at any time for any reason. A coal stove operates differently from a wood stove in ways that matter specifically for heating a living room through a full winter day and night. Coal burns at higher temperatures than wood and burns much more slowly. A properly loaded anthracite coal stove, loaded with the dense, hard coal that burns cleanest and hottest, can maintain a steady burn for 12 to 16 hours on a single loading without any attention from the person heating the space. There is no wood to split, no fire to tend through the night, no waking at 2 in the morning to reload a stove that has gone cold. The coal is loaded, the dampers are set, and the stove burns steadily and evenly at a temperature that can be adjusted through the damper controls with a precision that wood fires rarely allow. Part 2 continues with the remaining heating methods, including propane and kerosene heaters. The architectural principles that make all of these methods perform better than their fuel inputs suggest they should. The specific role of soapstone and thermal mass in maintaining overnight warmth, and the cost comparison that explains why Amish families consistently spend 60% less on winter heating than the average American household, spending money on a system that delivers inferior comfort by every thermal measure that matters. The fourth method is the propane or kerosene heater, and it occupies a specific role in Amish heating strategy that is worth understanding precisely because it is not the primary heat source. It is the fast response supplement. A masonry heater charged overnight is still radiating warmth at 7 in the morning, but a mudroom where wet coats and boots come in from the barn needs immediate heat that no thermal mass can provide on demand. A propane heater in that space delivers warmth within minutes of lighting, requires no electricity to operate, and costs $200 to $300 for a unit that will last decades with basic maintenance. Kerosene heaters serve the same supplemental function and add a quality that Amish households value specifically. They produce warmth spectrum light simultaneously. A kerosene heater running in a corner of a living room on a dark January afternoon is contributing heat and a quality of warm amber light that the household would otherwise need a lamp to produce. The dual function is not incidental. It is the same layered efficiency logic that runs through every Amish heating decision, where a single fuel expenditure is expected to serve more than one purpose before it is considered worthwhile. The architectural principles that make all of these methods perform above their apparent capacity share one foundation: thermal mass combined with low ceiling volume. Amish living rooms are not large open-plan spaces with cathedral ceilings that allow warm air to collect 12 feet above the people sitting in them. They are rooms with ceilings at 8 feet or below, with walls built from materials that absorb and hold heat, and with floor plans that concentrate the household's activity in the spaces that the heating sources serve most directly. Heat rises into a loft where family members sleep, warming sleeping spaces passively from the living area below without any additional fuel. Soapstone placed near heat sources during the day stores enough thermal energy to continue radiating through the night at surface temperatures comfortable to the touch. Amish families place soapstone slabs on stove surfaces for hours, then move them wrapped in cloth to bed areas in the evening, a practice that requires no fuel expenditure beyond what the stove was already consuming, and that maintains sleeping warmth through the coldest nights without any heating system running in the bedroom at all. The cost arithmetic across a full winter season for an Amish household using a combination of these methods consistently comes out between $600 and $1,000 in fuel expenditure. The average American household running a gas furnace spends between $1,500 and $2,500 for a winter that is often less comfortable by every thermal quality measure that matters. The Amish did not develop these methods to save money. They developed them because the infrastructure of the modern utility grid was something their communities chose not to join. And that choice forced a quality of engagement with the physics of heat that most American homeowners have never needed to develop. The knowledge that keeps a Holmes County living room warm in January without a gas line is not primitive knowledge. It is sophisticated knowledge that the modern heating industry displaced rather than improved upon and that an entire community of 360,000 people has maintained in working practice, while the rest of the country pays a utility company to deliver an inferior result at 3 times the cost. The warmth in that living room is not a mystery. It is physics applied carefully by people who could not afford to apply it carelessly. That knowledge has always been available. It was just easier to sell you a thermostat than to explain it.